In this recording, we talk about non-inverting op-amp with reference input. We start from a basic op-amp circuitry like this. So we have V in and non-inverting input, and R1 here, R2, and V out, reference voltage here, 0 volts, and V out. So we follow the current direction, assume the current is flowing here, cannot go into the op-amp, so flows through R2 and go to V out. So we have the transfer function looks like 0 volts minus V in. Remember this node here and this node here are same potential. They're both V in now. Divide by R1 equals V in minus V out divide by R2. Okay. Let's rearrange this equation, remove the V out to this side. So we have V in minus V out and divided by R2 equals minus V in divided by R1. Okay, let's further simplify this. We move R2 to this side. So we have V in minus V out is minus R2, R1, and V in. Okay, so we have V out equals to minus V out equals to minus R2, R1, V in minus V in. Okay, so V out equals R2, R1, V in plus V in. To combine this, we have V out equals 1 plus R2 divided by R1 V in. Okay, we are familiar with this. Is the basic equation, the transfer function for a non-inverting input op-amp. Okay, so rewrite this over here. So V out equals 1 plus R2 divided by R1 times V in. So the amplification is always bigger than 1. So it's and 1 plus R2 R1 always bigger than 1. Okay. Now let's think about the case. Let's look at this diagram here. Let's think about the case if the potential here is not 0 volts and we have a voltage level n called VR, a reference voltage. Okay, what that looks like. The transfer function is still the same, basically follow the same principle. We have VR minus V in divided by R1 equals V in minus V out divided by R2. Okay. So similar idea, we can try to solve the V out, and we have VR minus V in equals R1, R2, V in minus V out. Okay. Okay, let's solve it different ways. We can try to move the VR. We can multiply R2 on both sides. So we have R2, R1, VR minus V in equals V in minus V out. Okay, then we move the V out to this side, this stuff to this side. So we have V out equals V in minus R2, R1, VR minus V in. So V out equals V in minus R2, R1, VR plus R2, R1, V in. Okay, so V out equals, let's combine V in here. So we have 1 plus R2, R1, V in minus R2, R1, VR. Okay. Now look this equation here, this transfer function basically is very similar to the previous one, and with additional term with VR. Another way to look at this is linear function. We know that 1 ax a times v in plus b. Okay, so we let's write this properly. V in plus b, and a is your slope, which is equal to 1 plus r2 r1. It's also the amplification for the structure, and the b is the intercept. Intercept is right here. Okay, it's like if you have a, okay, roughly plot this. You have a input voltage V in and V out. So the transfer function will roughly looks like this. Okay, so it's amplified. This is the slope is A, and the intercept is B here. Okay, and let's erase this, and we can further simplify this or just run this in a different ways. And what we can do is we can subtract VR on both sides. So we have VO out minus VR equals to 1 plus R2 R1 V in minus R2 R1 VR minus VR. Okay, so it's also equals V2 V out minus VR equals 1 plus R2 R1 V in, and we take the VR out, and so it's 1 plus R2 R1 VR. Okay, so it's V out minus VR equals, okay, we can move the 1 plus R2 divided by R1 to the outside, so we got 1 plus R2 R1 and V in minus VR. Okay, now this looks very similar to the equations we have before. Okay, so for what we have is V out minus 0 volts equals to 1 plus R2 R1 and V in minus 0 volts. Okay, so it's basically it's the same format, same transfer function, but both V out and V in's reference to VR. Okay, that's the reference voltage. Okay. If we look this, when we know this transfer function, if we can come back to look this this plot, it's look this circuit is much easier now. If you think about this way, and this circuitry, what we have is if we subtract VR to other input and output, so we have this, we have V in minus VR, so VR minus VR, which is 0 volts, and V out minus VR, that's the output voltage in with respect to the output voltage with respect to the reference voltage. Okay, now this is turning into, because this is 0 volts, this is turning into a regular non-inverting input structure. So then you could just directly write this like V out minus VR 1 equals 1 plus R2 divided by R1 V in minus VR. So, and now, so this node, it's a reference node. Whatever the voltage input on this node, will just make the input, both input and output with respect to this voltage. Okay. Yeah, hopefully this can help you to understand a non-inverting op-amp circuitry whenever there's a reference voltage. With this reference voltage, if you look this equation, here. Here, with this reference voltage, you can amplify the signal. You can also offset the signal with certain values based on your requirements.